I hope you're having a great day. My objective of recording this video are two objectives. One is I'll explain to you interface and abstract class in Java. But the other objective is to show you how you can learn things on your own through using Gemini AI Studio. You can have your personal tutor who will understand you, will understand the things you know well, things you need support with it, and it guide you through the learning process. So I am now in my Eclipse. I need to start my Gemini Studio. So I go here and you click on, you go aistudio.google.com and you get into this page. You click on live audio to audio. We are here now. I will share my screen with Gemini, so Gemini now can see my screen, and then we'll go through to learn what we want to learn. So let's share screen. I will select the entire screen and let Gemini see everything. Hello, Gemini. Do you see my screen?
Yes, I can see your screen.
Yeah.
It looks like you're in the Eclipse IDE.
Correct. I'm going to record a video to explain to my student the abstract class in Java. And if we have time, we'll go to the interface as well. So you'll be with me to support me when I need help and ask you some questions, and you help me with that. So the first question, what is a really abstract class and why it is different from other classes? What makes it different from other classes?
An abstract class in Java is a class that cannot be directly instantiated. It's designed to be a blueprint for other classes, providing a common structure and methods that subclasses can inherit and implement. The key difference is that you cannot create objects of an abstract class directly, only from its concrete subclasses.
Okay, we'll look into this one later. But why do I need to have an abstract class? Why don't I use just a normal class?
Abstract classes are useful when you want to define a common structure and behavior for a group of subclasses, but you also want to ensure that those subclasses provides their own specific implementations for certain methods. They help enforce a contract, ensuring that essential methods are implemented, while allowing for flexibility in the specific implementations.
But isn't it the same like inheritance? In the inheritance, you can put the main things in the superclass or upper class, and then the subclasses can override and change the behavior of these methods. But what makes the abstract class different from inheritance?
That's a good point. While both abstract classes and inheritance involve subclasses, the key difference is that an abstract class cannot be instantiated itself. It serves as a template, forcing subclasses to implement specific methods. A regular class, even one involved in inheritance, can be instantiated on its own. Abstract classes are used when you want to define a common interface, but leave the implementation details to the subclasses.
But that concept of you cannot create an object from an abstract class, will it an added value or it's a limitation?
It's actually an added value. By preventing direct instantiation, abstract classes ensure that objects are created only from the concrete subclasses that provide the complete implementation. This helps maintain consistency and ensures that objects are created with all the necessary functionality, as defined by the subclasses.
Oh, that's a good. Okay, let's go ahead now. I'll go to Eclipse and create a new project, and then we will start looking at how we can create abstract class. Let's say abstract, I'll call it school management system, school system. Yeah, yes, let's call it just school system. And I need to hide this one. Oh, sorry, there's something coming on the screen. I just need to make sure okay, now I'm clicking on finish. And this is the project here. Within this one, we will create a class. I will create a class. Now we'll call this class, for example, person. Yeah, let's make it uppercase person. Now I just created one, and the package, the package will call it school, and the class we will call the class. What is the class name? Here's the name, person, and then we are done. Now we have a class called person. Like this is a normal class. How can I make this one an abstract class?
To make it an abstract class, you need to add the abstract modifier keyword before the class keyword in the class declaration. So it would be public abstract class person.
Is this correct now?
Yes, that's correct. You've now made the person class an abstract class.
So
This means that you cannot create direct objects of the person class.
correct. Now, can I add attributes to the abstract class?
Yes, absolutely. You can add both attributes and methods to an abstract class. These will be inherited by any classes that extend this abstract class.
So I'm creating one called string name, and another one maybe int age. This is good, yeah? So these two attributes we created for the abstract class. Do they have to
Yes.
be private, public? Can I use them as private?
You can use private access modifiers for attributes and methods in an abstract class. However, private members will not be accessible to the subclasses. They will only be accessible within the abstract class itself.
Now, I didn't say private or public. Will it be public or what it will be?
If you don't specify an access modifier, it defaults to package private, meaning it's accessible within the same package. If you want it to be accessible to all cub classes, you should use the protected modifier, or public if you want it accessible everywhere.
I see. Now, if I create another class, can I access the name directly from the other class?
If the name attribute is declared public or protected in the person class, you can access it directly from a subclass. However, if it's private or package private, you'll need to use getter methods to access it.
Now it is package private. So, okay. Now,
Exactly.
Yeah.
Since it's package private, it can be accessed by other classes within the school package, but not from classes outside this package.
this not only to my student. You notice how AI is helping me learn, and I ask any question and it guides me through that one. Now, Mr. Gemini, can an abstract class have a constructor?
Yes, an abstract class can definitely have constructors. These constructors can be used to initialize the attributes of the abstract class when an object of a subclass is created. However, you cannot directly instantiate an abstract class itself.
I see. So let me create this constructor. So public, we'll call it person, isn't it? And we're passing to it string name and int age. And then I'll come here. Correct me if I make any mistakes, please. Name equal name, semicolon, this dot age equal age. I know my students understand why we use this, because you have done this multiple times. Is this constructor correct?
Yes, the constructor you've written is correct. It takes a string name and an int age as parameters and uses this to assign these values to the corresponding instance variables of the person class.
Okay, in terms of methods, how the methods in the abstract class are different from the methods in a normal class?
In an abstract class, you can have both abstract methods and concrete methods. Abstract methods are declared without an implementation, meaning they have a signature but no body. Concrete methods, on the other hand, are implemented just like in a regular class. Normal classes can only have concrete methods, not abstract ones.
I see. Now, if I want to create an abstract method here, what is a good abstract method for a class like this one, a person class?
A good abstract method for a person class could be something like getDetails. It would define the expectation that all subclasses must provide a way to get the details of a person, but leave the specific implementation to the subclasses, like employee or student.
Okay, I will make an attempt to create an abstract class and correct me if I make mistake. I will make a mistake on purpose, yeah?
Okay, go ahead and write the method, and I'll let you know if there are any issues.
Is this correct?
Not quite. An abstract method should not have a body, so you need to remove the curly braces and end the declaration with a semicolon. Also, you need...
Okay, let me delete this before you tell me the other mistakes I have. Yeah, I'm done with this. What else I should correct?
The other mistake is that if a class has any abstract methods, the class itself must also be declared abstract. So you need to add the abstract keyword before the class keyword in the class declaration.
It's already there. Yeah, it's public abstract class.
Yes, that's correct. Adding the abstract keyword to the class declaration makes it an abstract class, which is necessary when it has abstract methods.
Is the way I wrote abstract method correct is by starting by abstract, or can I say public abstract?
You can declare an abstract method by starting with abstract followed by the visibility modifier, like public abstract void get details. The order of abstract and the visibility modifier doesn't matter, so public abstract or abstract public are both valid.
Very good. Now let's get concrete. You said there is something called concrete method. What is a good concrete method for a class like person?
A good concrete method for a person class would be something like getName. It could simply return the value of the name attribute. Since it has a specific implementation, it's considered a concrete method.
Do I need to use the word concrete in the method declaration?
No, you don't need to use the concrete keyword. Methods that have an implementation are automatically considered concrete. You just define them like any other method in a class, without the abstract keyword and with a method body.
Is this correct method?
Yes, that is a correct definition for a concrete method. It has a method body and provides a specific implementation.
Very good. Now we can add other concrete and abstract methods. Of course, yeah. Is there a limit for how many abstract method I can have and how many concrete?
No, there isn't a specific limit on the number of abstract methods or concrete methods you can have in an abstract class. You can have as many as needed to define the required functionality for the class and its subclasses.
Yeah, I heard you saying that the subclass need to write body for every abstract class. Is that correct?
Yes, that's correct. Any concrete class that extends an abstract class must provide implementations for all the abstract methods inherited from the abstract class.
Yeah.
If it doesn't,
yeah, that's mean if I have so many abstract methods, I need I make it complicated for people who create subclass from that abstract class, because they need to write implementation for every abstract method.
Yes, that's a good point. Having many abstract methods in a base class can increase the complexity for subclasses, as they must implement all of them. It's important to balance the use of abstract methods to ensure the base class design is practical and maintainable.
Is there a guideline of the maximum number of abstract class you can have in an abstract method you can have in an abstract class?
While there isn't a strict rule on the maximum number, a common guideline is to keep the number of abstract methods focused on the core functionality of the base concept. If a class has many abstract methods, it might be a sign that the design could be reevaluated, perhaps suggesting the use of interfaces or splitting the class into smaller, more focused classes.
Okay, that's very good. Now let's create another class that will use this one. So I'll go and create a new class. We will call it student in this case, which type of person.
Okay.
And I'm just creating it. Now, how I can make it now use the abstract class as the parent class? Is it same thing like what we use in inheritance, extends, or something different?
Yes, you'll use the extends keyword to make the student class inherit from the person class, just like with regular inheritance. This means the student class will need to provide implementations for the abstract methods from person.
Yeah, I did that one. Now, can I add, of course, I can add specific attribute to the student, yeah?
Yes, absolutely. You can add specific attributes that are unique to the student class, such as their student ID or courses they're enrolled in. This allows you to create specialized properties for the student class while still inheriting the general properties from person.
Yeah, I'll just simplify it. I'll add one called course, yeah? It can be a list, but just to simplify it, and you can create an array list, and you do all things we have done in previous lessons, but now we'll just create a course as attribute. Maybe you should add ID, sorry for that. So we'll add string ID. I'm using ID as string because sometimes the ID includes some special letters or characters. This is good now. Of course, I can create now a constructor, yeah? These things I know, so let me do it myself. Let me make one constructor. I'll call it student, and now what are the parameters I need to pass here? Mr. Gemini, Mrs. Gemini, sorry. What should I pass here?
You should pass the parameters that needed to create a student object, such as the student's name, age, and any other relevant information. Looking at your code, it looks like you'll need to pass the student's name and age first, since the student class extends the person class. Then you'll need to pass the course and ID for the student.
Correct.
Okay.
ID, I did it. Now maybe should make this smaller here. And this is the constructor. Now, of course,
Yep.
sorry, call this one, sorry, just comma here, just to fix things. I'm sorry for jumping in. Okay, so these are all the parameters I need. What are the name, age, course, and ID, yeah? So how can I now, usually when I inherit from another class, I can call the constructor of the parent class using the word super. That's in the inheritance. Is this the same thing here in the abstract?
Yes, you can still use super to call the constructor of the parent class, person, from the student constructor. You'll need to pass the name and age parameters to the super constructor call.
That's what I did. And now I know the rest. I will set the other two things. So yeah, this we know, yeah. So I'm setting the course to the course, okay, and then we'll set this ID to ID. Is this constructor good?
Yes, the constructor looks correct now. You're properly calling the parent class constructor and setting the course and ID attributes of the student object.
Yeah, that's very good. Now, what about the other things I need to do? What I need to do here?
You've set the course and ID properties. Now, you might want to add some logic to initialize any other specific attributes for the student class, or perform any other necessary setup operations within the constructor.
Yeah.
If there are no other...
Yeah, but in this super class or the abstract class, I have this method, the abstract method, this one, yeah? Now, do I need to implement it in the subclass, or what should I do with this method?
You need to implement the getDetails method in the student class because it's an abstract method in the parent class, person. Your student class must provide a concrete implementation for that method. You can define what details of a student should be returned when getDetails is called specifically for a student object.
Okay, so what I did, I override, because I assume I need to override it because it's already in the superclass, so it has to be overridden here, yeah? Okay, so, and here I will just display the details. Is that correct?
Yes, that's correct. You've successfully overridden the getDetails method in the student class. Now, within this overridden method, you can add the code to display the specific details of a student, such as their name, age, course, and ID. That's the right approach for implementing the abstract method in the subclass.
Yeah, I'll do this, just add some spaces in between, name, then we'll add age, we'll add space here, okay, semicolon, that's one, and then another line to display the course and ID, system out dot print.
Right.
I'm assuming I'm doing things right. If you think I'm not doing it right, just tell me this is wrong.
You're doing great. Everything you've done so far with overriding the method and displaying the details is correct. Just continue adding the rest of the details you want to display for the student.
You are very helpful and very kind.
Thank you. I'm here to help in any way I can. Let me know if you need further assistance with your code.
Yeah, I'm still working on this, yeah. I think I'm done, but I see println, there is an issue with println. Is that an issue with it, or it will be working fine?
The issue is that you've used two separate system.out.println statements to display the name and age, and then another statement for the course and ID. If you want to display all the details on a single line, you should combine them into one system.out.println statement, separating the values with commas, or whatever formatting you prefer.
Yeah, but this is, the syntax is correct. There is no issue with, or if I compile it, it will run.
Yes, the syntax you've used is correct, and the code will compile fine. It will just display the name and age on one line, and then the ID and course on the next line.
Yeah.
If you intend...
And that's what I want to have. I want the name, age up, and then ID and course on the other line. That's what I'm looking. Is there anything else I must do here in the student class to make it work properly?
No, you've correctly implemented the necessary parts for the student class. You've defined its attributes, created a constructor to initialize them, and overridden the getDetails method to display student information. The class is now ready to be used.
Now, let's go and create another class, a main class, yeah? So we'll go into class. I will select add public static void. I'll just call it main for simplicity. This is my main class where I can, now I would expect like what I did before in inheritance, that I can now create an object of the subclass, yeah? So my subclass is student. I can create S1, for example, equal new, and I can call the constructor. Is that correct?
Yes, that's the correct way to create an object of the student class. You use the new keyword, followed by the student constructor, passing the required arguments to initialize the student details.
Now, maybe I'm mixing things, but let me see if this is correct. So this line, I assume, will create an object called S1, and it's basically calling the constructor of the student class. Just I want to make sure the orders are the same. Let me have a look here. Yes, the course, then the ID, that's correct. I think the order is correct, isn't it? Okay. So now, can I call, what should I do now? I can call the method, yeah? I think there's one called get details. That's the one we did override, isn't it? Let's call get details. Okay. Is this problem correct?
Yes, that's correct. The line student S1 equals new student creates a new object of the student class and assigns it to the variable S1. It's calling the student constructor with the provided parameters, name, age, course, and ID. And yes, the order of the parameters matches the constructor definition in the student class.
Let's run it. Let's run it. There is an error here in our code. Existing error in the code, and I need you to help me with fixing it. So here is the what it's saying here. Let's go up. It's saying now there is an issue in the main class. There's something wrong.
It seems there's a compilation error in the main class, specifically related to the system.out.println method in the student.java file. It looks like you're trying to print different types of arguments than the method expects. You might need to adjust the arguments you're passing to println or convert them to strings before printing.
So I need to go where? I need to go to the student class and look at this one. Remember the one had issue with it, yeah? So let's go there. This is the student class, and here is the issue that we said we may have an issue with it. Okay?
Yes.
I think what missing? Do you see the error? The plus. In Java, we do not use comma, we use plus. Yeah? So that's the error. I found it myself, Mr. ChatGPT. Is that correct? Just remember, Java is different from C and other languages. The plus is the way you can add text to each other. Okay, so let's run it now. Perfect, it's running perfectly. So we're getting student Hamad and getting the details.
Yes, using the plus operator for string concatenation in Java is correct. It properly combines the strings and variables or printing.
Very good, thank you for that. Now let's add another object. If I want to add another object here, and I want to do this and add S2, call it now, and call him Ahmed. Yeah, Ahmed is a good person, and he's very young, not like this, 60 years old, and his ID is not like me, yeah, no. And then S2, and now that's it, okay? Student S2, sorry, what is this? S2, okay? So if you run this one, we'll get both of them coming. Now I have a question now. I heard you saying that if I add another abstract class here, then I need to implement it. So suggest to me another abstract class to the person class.
You could add another abstract method to the person class, like public abstract void display role. This would require both student and potentially other classes to implement how they display their specific role.
That's a very good one. So I added display role here. Now, if I run my code, what error I'll get? There is an error, yeah? That's what is that error? Why this error is coming? It's a warning, yeah? It's not an error, it's a warning. So the code still run, as you can see, and I get the result, but I get a warning that there's something going on. So I need to be careful with it. And this coming from my, if you look at my student class, it shows there is red here. What the reason for this red?
The warning you're getting in your student class is because you've added a new abstract method, display role, to the parent class, person. Since student is a subclass of person, it needs to provide its own implementation for that abstract method. To fix the warning, you need to add a display role method to the student class and provide the specific implementation for it there.
That's the message. So if you have an abstract method, you must have its implementation in the subclass. So we'll come here and we'll also override, and then we will add this method here, and we'll get its implementation. We'll say system, I'll just make it simple one, yeah? System dot out dot print ln, say I am a student, yeah? Is this good implementation for this method, Mr. Gemini?
Yes, that's a perfectly valid implementation for the display role method in the student class. By adding the override and providing the specific behavior to print I am a student, you've fulfilled the requirement to implement the abstract method inherited from the person class. This should resolve the warning you were previously seeing.
Very good. Let me just run it.
Okay, it looks like the program is running. What are you trying to...
Yeah, this is good. Now let's create another class. We call it teacher, yeah? And so we can see how things will go. So I'll come here and add a new class. Student, you see how Gemini is amazing, yeah? It helps you to learn, and it can be your tutor or support. Okay, so I'm creating a teacher. Of course, I need to say extends.
Yes, I'm ready to assist you with creating the teacher class. Just tell me what code to add.
You are very good. I can add here string department. Yeah? So the teacher may be from a specific department or major he's teaching, yeah? Okay, just add department. Okay. Now I need a constructor, isn't it? So how I can write the constructor? Let me make a mistake and you correct me if I make a wrong mistake, yeah? Who noticed my mistake? Who noticed my mistake?
You've written public void teacher, which looks like a method, not a constructor. A constructor should have the same name as the class and no return type. It should be public teacher.
Oh, you're right. Department, I'll fix it now. So there should be no void in the constructor, yeah?
Exactly. The constructor doesn't have a return type. Now, you need to initialize the department variable and call the superclass constructor to initialize the inherited variables.
Which the name and age.
Yes, you need to pass name and age to the superconstructor. Go ahead and add those.
I did that, but let me just fix those. Say this is string, this is int, and this is string. So if you make any mistake, Gemini is ready to support you. So this dot department equal department. Student, you have no excuse to learn and advance your knowledge in this era where we have AI is there to support us, not to do the work for us, it's to work with us. It's important to work with us. Okay, so that's the constructor. Now I need to override those two methods which we have, isn't it? So let me take them from the student class. Yeah, I'll copy these two methods in the student class and take them to the teacher. Yeah, because I'm going to override them. And here we're displaying, I think I removed this line because I have only name, whatever, and then the department, isn't it? Plus department. Yeah, these are the only thing I can do because here I have only the department, I don't have ID. And the role I can say I am a teacher. Yeah, I I am a teacher. I'm an innovative teacher. This is everything looks good in the teacher subclass. Mr. Gemini, are you still here? It seems Mr. Gemini stopped doing thing because it was listening to me. Let's see if we can get it to start again. Hello, do you still see my screen? Connection failure. Yeah, it has a limit, I think, on how long it will be with you. But the good thing, you can restart it again, and you can again do the things. If it stopped, you just do this. You come back here into share screen. You select the entire screen, and you come back here. Okay, welcome back. I think you can see my screen, and I'm not sure if you remember what I was doing.
Yeah. You were creating a teacher class that extends the person class, and you overrode the get details and display role methods.
Yeah, just to remember, I had an abstract class called person, and then I created from that a subclass by extending person, which is an abstract class, and I must override these two abstract methods. And also I have another one called student, which again has its own parameters and constructor calling the abstract class, and then I'm overriding the two methods. I want to go to the main class where I have created two students. Now I need to create a teacher. Yeah, let's create a teacher. I'll call it T1 in this case, equal new teacher, and I need to pass the parameters. I'll call the teacher, what's his name? Salim. Salim is a very good teacher, and his age is 35. He's young, he just finished his PhD, and his department IT, or computer engineering. Good? Is this correct? ChatGPT, Gemini, you hear me? Yeah.
Yes, I can hear you clearly. The code for creating the teacher object looks correct.
Get details. I'll get the details of the teacher. Okay. And I'll ask the student here also, S1, to get the student role. Yeah. Get. There's something called get student role, isn't it? So where is the student? Get display role. Yeah, display role. We will call this display role as well in the main class. Get one display role. Yeah, that's it. I'll just keep only one student. It's clear to us. And then here I will also take T1 and display role, same thing. I can't remember how I spell it. Display role, and I have to use T1 here to refer to this one. Okay, looks good, yeah?
Yes, that looks good. You're using the get details and display role methods correctly for both the student and teacher objects.
Yeah, so I'm getting now, when I run it, I get the student name, his age. This is not a student, 60 years. Learning never stop. You can learn at any age. And then you have the ID and the course. Then you have I am a student, and Salim is a teacher, and he is in IT department, and that's his name. Now, one thing I have a question for, I have a method, concrete method here that I never use, this concrete method. So can I use it now? Let me use it in the main class, yeah? So let's get here and I want to call that method, yeah? So I can call s1 get name, okay? Now this is good, but let me, if I do this, we'll get nothing displayed in the screens as we know. So we need system dot out dot print ln, and then we can have here name equal plus get name and close this. So I'm calling the concrete method from S1, yeah? So this is basically, I'm calling the concrete method from the abstract class. Because it's a concrete, I can call it directly. And I can do the same thing. Yeah, please, explain more.
You can directly call the getName method because it's a concrete method in the person class, not an abstract one. This means it has a defined implementation, so objects of subclasses can use it directly.
Yeah, very good. So let's run. And it works very well. So get the name as well again, because we ask for it to be displayed again here and displayed again. Very good. So this was helpful, Mr. Gemini. Can you just summarize what we have done in this video which we're recording?
Sure. In this video, we discussed how to define an abstract class with abstract methods in Java. We then created subclass classes that inherit from the abstract class and provide implementations for the abstract methods. We also demonstrated how to use inheritance and how concrete methods from the abstract class can be called directly from subclasses.
Very good. Now, what advice do you have for my student who want to improve their skills in this area?
I would suggest practicing with more examples of abstract classes and inheritance. Understanding the concepts of abstraction and polymorphism thoroughly is crucial. They should also try to apply these concepts in different programming scenarios to solidify their understanding.
Yeah, if you give them guidelines, what are the things they should consider when they are creating or using abstract class? Give them just some steps they need to follow.
Sure. First, they should consider whether a base class needs to have some methods implemented and others left abstract to be implemented by subclasses. Second, they should ensure that all abstract methods are implemented in the concrete subclasses. Third, they should use abstract classes when they want to define a common structure for related classes, but leave some specific implementations to the subclasses. Finally, they should remember that abstract classes cannot be instantiated directly.
Okay, in our next video, we'll discuss interface in Java. Now, give us just a way to link these two together. What's the difference between an interface and abstract class?
While both abstract classes and interfaces are used to achieve abstraction, an abstract class can have both abstract and concrete methods, whereas an interface only contains abstract methods and constants. Also, a class can implement multiple interfaces, but can only extend one abstract class.
I see. So here when I say extend, I can't extend two, saying comma, contract, or for example, or something like that. It has to be only one, yeah?
Yes, that's correct. In Java, a class can extend only one abstract class, but it can implement multiple interfaces.
I see. So I have two interfaces. I can put comma here, and here you're saying implement means I don't use extend. I use implements, isn't it?
Exactly. If a class is implementing interfaces, you use the implements keyword, and if it's extending an abstract class, you use the extends keyword. You can have a class that both extends an abstract class and implements multiple interfaces.
Okay, thank you very much. I really enjoyed this session. I hope my student will enjoy it. And as I said, there are two objectives we had. One is to get you, my student, to learn abstract class and how it can be used and when we need to use it and what are the rules that need to follow to use abstract class. But the other bigger picture is how to can use Gemini and AI Studio to help you learn anything. And this can be applied to any other subject that you want to learn. You just start working on it and you have your questions, and Gemini will be guiding you through the steps.
That's a great approach. Using AI tools like Gemini to guide your learning can be super helpful across many different subjects. It's like having a personal tutor to help you understand complex concepts and answer your questions as you go.
Okay, so thank you, Gemini. I hope to see you in the next video, and I hope we will be working together for some time to help students and teachers use the best of AI.
You're very welcome. I'm excited to continue working with you to help students and teachers make the most of AI in learning. See you in the next video.